So in this problem, I will do a mixing word problem involving a linear differential equation. Okay, so we have a word problem. At time t equals 0, a tank contains 4 pounds of salt dissolved in 100 gallons of water. Suppose that the brin containing 2 pounds of salt per gallon of brine is allowed to enter the tank at a rate of 5 gallons per minute, and that the mixed solution is drained from the tank at the same rate. Find the amount of salt in the tank after 10 minutes. So this is actually an initial value. Find the amount of salt in the tank after 10 minutes. So here we have an image. I'm not really, here's the image. Here's the, I guess this is the brink right here. And then water is pouring in. And yeah, so there's water and salt mixed, and it is pouring out. So if you have to read this problem, that's fine. So first what I have to do is find dy dt. So dy dt. So in our case, it would be it's going to be rate in, rate out, because water is pouring in and then it's coming out. So it's going to be rate in minus the rate out. Okay, so let's find the rate in and then the rate out. So the rate in, I believe it is given. It says, suppose that the brin containing 2 pounds of water, 2 pounds of salt water per gallon of the brin. So 2 pounds per gallon. So that would be expressed as 2 lbs per gallon times allowed at a rate of 5 gallons per minute. So it's going to be 5 gallons per minute. And as you can see, the gallons cancel. So you're left with 10 pounds per minute. Okay. And then the rate out is that's a tricky one. It says at a time of t equals 0, a tank contains 4 pounds of salt dissolved in 100 gallons of water. Suppose the brin containing 2 pounds of salt water per gallon of brin is allowed to enter the tank at a rate of 5 gallons per minute, and that the mixed solution is drained from the tank at the same rate. Find the amount of salt in the tank after 10 minutes. So I'm going to say our rate out will be yt, because we don't know what yt is, over 100, right? Yeah, 100 gallons or 100. And then here would be pounds per gallon. Yeah, because it was 100 gallons of water, right? And then we're going to times it by the 5 gallons per minute. And then that gives you YT 20, and your units will see what happens. The gallons cancels, so you're left with pounds per minute. Okay, so I think now we can find our dy dt. Our dy dt is the rate in is 10 minus the rate out is y over 20. Okay, so now that we found our dy dt, this is a linear differential equation, so we got to put it in the the standard form of a linear differential equation. So I have to move this negative y over 20 in the middle. So I'm going to add y over 20 to both sides. So this cancels. So you're left with dy dt plus y over 20 equals to 10. Okay. Now we have it in standard form. Or if you want, you can rewrite y over 20 as the same thing as 1 over 20y, right? Okay. So when you're doing solving for a linear differential equation, you got to figure out your p of x and your q of x. So, or in our case, our p of t and our q of t. So our p of t is 1 over 20, and my q of t is 10. Okay, so now put it in the formula. So it's y equals I of t be the integration of I of t times q of t dt plus c. Oh, then we have to take our integration factor. So let me find that first. So it's to find the I of t is e raised to the p of q. So our p of t is 1 over 20. And then t, no, it's 1 over 20 dt, sorry. There, see our p of t is 1 over 20. Here, let me erase this. So what is the integration of 1 over 20? It's just 1 over 20t, right? So the I of t is going to be e to the 1 over 20t. Okay, so it's going to be y equals 1 over I of t is e to the 1 over 20t. And then it's the integration of I of t. What is I of t? It is e to the 1 over 20t times q of t, which is 10, plus c. So how do we take the integration of this part right here? So if you want, you can rewrite it as the integration of e to the 1 over 20t. And then this 10 is a constant, so you could just take that out. And dt, so how do you take the integration e to the 1 over t? It is use substitution, and that is going to be, so you're going to use u as 1 over 20t, and then if you take du, it would be, what's the derivative of 1 over 20? It is 1 over 20. dt. So you're going to replace this with e, and then you're going to replace 1 over 20t with u, and then you're going to replace dt with du. I mean, wait, right on this step, you have to get rid of this 1 over 20 because we don't have 1 over 20 as a constant, so you have to multiply both sides by 20. So this is 20 du equals to 20 times 1 over 20 is just dt. So you can replace dt with 20 du. 20 is a constant, so it's 20 here, and then you still have you can put it outside, and then you still have a 10, and then you have a dt, I mean a du. And what's the integration of e to the u? It's just e to the u, and then what's 10 times 20? 200. So that would be 200 E, and then your U is 1 over 20 T. Okay. So let me put it right here. Your Y is going to be 1 over E to the 1 over 20T times E to the 1 over 20T is 200 E to the 1 over 20T. And plus C. So if you FOIL this out, what's 1 times this? That's just going to be 200, and then the E to the 1 over 20T cancels because they're the same on top and bottom. So you're just left with 200 plus C, and then it's C of 1 over E to the 1 over 20T. And then what you could do is you can solve, we have initial value. Our initial value was at time 0 equals a tank contains 4 pounds. So that's your initial value, 0.4. So 0 is your X, 4 is your Y. So it's going to be 4 equals 200 plus C. And then it's 1 over E. T raised to the 0 is E to the 0. And E to the 0 is 1. So you're left with 4 equals 200 plus C. And then solve for C. So C is 4 minus 200 is negative 196. Okay, so I'm going to have to erase. So go ahead and pause if you need to. I'm going to erase this part. I need more space. So Y equals 200, and then our C was negative 196. And then it's, what is, let's see, 1 over 1 over 20T, that could simplify as, what does that simplify to? That simplifies as, so it's 1 divided by E to the 1 over 20T. So that would be, oh, that'll just leave it as it is. And then yeah, let's just leave it as it is. So it's going to be negative 196, and then let's just leave it as it is, E to the 1 over 20T. And then what you're going to do is find the amount of salt after 10 minutes. So our T is time, so it's going to be Y of 10. That's 200 minus 196, and then that's 1 over E, and then replace T with 10. So 10 times 120 times 10, that is 10 over 20, which can be reduced by 10, which is 1 over 2. And we put that in the calculator, that is about 81.1 pounds. Okay, so your final answer will be 81.1 pounds. Okay, so this is an application word problem involving linear differential equation. And that wraps it up for this video.